Hello and welcome back to my channel. Today we're going to talk about more of the nerdy questions behind skincare. I'm excited to talk to you guys today. I did a lot of research and it's really helpful. This is going to be really helpful in digging down and understanding ingredients in skincare. So if you watch the introduction, I mentioned that I'm a rangeland scientist, and that means that I deal with landscape level scientific questions. And a lot of the topics and questions around skincare and skincare ingredients have to do with microscopic level questions. And this can be really intimidating. Even as a scientist, I'm intimidated by this. I did not do well in chemistry. It doesn't come natural to me if I can't see it. So I made an extra effort to simplify these terms, just hit on the points that are super important and not get bogged down in the details. So both of these, or this topic, you could really dig deep. That's not necessarily what we're going to do today. We're going to talk about what we need to understand for skincare. And so I have so many ideas for videos on this channel that I'm going to start separating them into categories. So this is going to be ingredient knowledge basics. And last week I talked about active ingredients. If you're curious about what active ingredients are, go back, check that out. It's also going to be ingredient knowledge basics. And then we'll have other categories. I'm excited to share this with you. I just need to organize my thoughts. So today, the skin. The skin is a barrier, but it's also a membrane. So what are the nature of particles that can go through the skin? So we know that skin helps keep bacteria out. It protects our body against moisture loss, so it keeps moisture in. It helps regulate temperature. It also keeps harmful substances out, dirt or some other foreign bodies. It serves as a very effective barrier, but we know some things can go through it. So what are the nature of those particles? So the first thing you want to kind of understand is that the skin is this really complex thing. It is made up of different types of layers. So it's a heterogeneous substance, meaning it has different parts. It's not all the same. There's two main layers, and one is hydrophilic and one's lipophilic. So that means that in one layer, particles that dissolve in water will bind to it easily, and in the other layer, particles that dissolve in fats will bind to it easily. And this affects how particles pass through the skin because each layer has affinity for a different type of particle. The upper layer of the skin is the layer that contains the fats, and substances with the ability to dissolve in fats have an easier time of penetrating the skin. So when you're looking at skincare ingredients, keep that in mind. If you look it up and it says that they are fat soluble, that's good. They're probably going to penetrate the skin pretty well. And the second thing is the molecular weight. Now the molecular weight refers to the size of the particle. If you really want to get into what the molecular weight is, go to Wikipedia and look it up. And you can learn about grams per mole and all of that. I'm not going to get into it today. It brings me to another point. This is a side note. Wikipedia. That's a great place to get some general information. Refer to the sources. You can see what kind of sources were used to build the Wikipedia page. You're not going to use it as a citation in a research paper, but it doesn't mean the information is not correct. So Wikipedia gets a really bad rap, and I don't think it should. It's very useful. Go ahead and use it. Just don't use it as your only source. It's nice to corroborate some of those stances on Wikipedia. Okay, side note over. Back to the topic at hand, molecular weight. And how does it relate to skin penetration? So there's a general rule called the Dalton rule, and the Dalton rule says that there's a threshold at approximately 500 grams per mole, and above 500 grams per mole, your skin is pretty good at keeping substances out. Below 500 grams per mole, particles can easily penetrate the skin. Common skincare ingredients, you'll read, between 200 to 400 grams per mole is a typical size, which is good because if you're putting it on your skin, you're wanting it to penetrate and do something to your skin, not just sit on the surface in most cases. Okay, so what are some items, some substances that we hear about? Fatty acids. We hear a lot about fatty acids. And so coconut oil is about 50% lauric fatty acid, which is 200 grams per mole. There's other common fatty acids, including oleic, 280 grams per mole, and palmitic fatty acid, which is found in olive oil, is 250 grams per mole. So your fatty acids range from 200 to 300 grams per mole. That makes them very effective moisturizers. Another substance we hear about, collagen. We know that our skin and our bones naturally produce collagen, and that's what keeps your skin looking young and plump. And as we age, collagen production slows down. So it sounds like it would be a good idea to just add more collagen to the skin. However, it doesn't work like that because about 90% of the naturally occurring collagen is type 1, 2, or 3, and the molecular weight of collagen type 1 is 1,300 grams per mole. It's way too large to penetrate the skin. It will not. It will sit on top. Now, there is technology that can break these large collagen particles into smaller collagen particles, and there's research that's looking into how that can be used to treat osteoarthritis or osteoporosis and improve bone density. But as far as skincare, the technology is not advanced to the point where those smaller collagen particles can bind with the existing naturally produced collagen in your skin. So adding collagen to the top of the skin, it's not going to work because the particles are too big. The best thing to do is to use ingredients that enhance your skin's natural collagen producing capacity. That's a topic for another day. You guys will have to tune back in. So when you're considering ingredients in personal care products, you can do a quick search and see what the molecular weight of these are and if they're fat soluble or water soluble. And that'll tell you a lot about the chances of them penetrating your skin. You'll also read about penetration enhancers, which sounds dirty, but that's not what we're talking about here. Penetration enhancers. They use these a lot in topically applied drugs. So, I mean, even something like, the birth control patch or whatever, for that estrogen to get into your skin, they put some other ingredient in there to improve the penetration. The research was not clear on this. In some studies, there was no statistical significance in the difference between drugs that used penetration enhancers and those that didn't. So the findings were inconclusive. In others, they would test a bunch and one would have a slight advantage and the others weren't. You still see them in cosmetics. I just did not find any research to really support their use and to get more particles into your skin. So read the ingredients. This will give you a little context into what kind of ingredients you want to look for. And when you look them up, when you do a Google search and you go to EWG or some other website and it tells you that it's fat soluble or it's water soluble or what the molecular weight is, this will give you a little context into what that means related to skincare. I'm also going to put an article in the comments. Some researchers looked at over 240 plant-derived oils and broke them down into fatty acids. So I find this very helpful because you read the back of something and it has galip or nangai oil in it, but you don't know what the fatty acid composition of that is. Or even derivatives of coconut oil. They broke those down. So, there's pure coconut oil and then there's all these derivatives. What is the composition of those and what fatty acids do they have. And then you can find more information related to those specific fatty acids. So check that out. It's going to be in the comments. It's downloadable as a PDF. So I love that. Open source scientific information. It's great. So please let me know if you have any questions. Like, share, subscribe. I am looking forward to doing more videos. And don't forget to follow me on Instagram at Erin's Beauty Bloom.